Hi guys, welcome to the first episode of this series. As you might know, in this series we are going to implement a color switch game using Flutter and Flame Game Engine. So this is Iman Neo, welcome to my channel. Today we are gonna learn some basic concepts of game engines and see how Flame works. So let's get started. First of all, let's create our new project. I will create a new Flutter project. I will name it Color Switch Game, and it is an empty project. So I hit the create button. Okay, so as you see, we have a blank project here. It has only a main app and a text inside that. So we are gonna replace it with our game later. At first, we need to import the Flame dependency. If you open the docs here, you will see that you can add the Flame dependency like this, 182 dependencies. Okay, let's do a pop get, and I hope we have Flame now. Let's import it. Flame. Yes, we have Flame dependency. Now we need to know a little bit about how Flame works. So I will open the documentation and we can go through a step by step. At first, I will open the file structure. So the convention that Flame suggests is like this. So if you follow this approach, then you can access to the files like this. For example, it says flame audio.play explosion.mp3. So now Flame knows that explosion.mp3 is inside the assets audio directory. Yes, it is a minor important thing to know. And we have a game widget. As I say, Flame itself is a widget, so you can combine it into your Flutter widget tree or Flutter application. In most cases, we have a full screen of this game widget. For example, in this case, we have a run app, so we don't have any material app or Cupertino app on the top of widget tree. Instead, we only have a game widget. So Flame handles everything for you. You don't need to add a Cupertino app or material app. But if you have some use cases that you need to have a material app, for example, handling roads, deep links, or anything else, it's okay. You can add the Flame widget into the pages that you have. So you are free to do anything you want. So I will copy paste this code. Let me full screen the page, and we don't need to have a material app anymore. I will remove it because our game widget is the root and it accepts an instance of our game. So if you open the game, game is an abstract class. We have Flame game, so it is recommended by the Flame engine to use Flame game parent class instead of extending the game itself. So here I will create a my game class which extends Flame game. Okay, now we have a blank game. Let me run the game. Okay, now we have a game. Let me put it inside this window. And yes, as you see, we have a blank game. We have nothing here. For example, we can take a look at this class to see what functions can we override. I'm pretty sure that we had something like background. Yes, background color. For example, you can override this method to tell the flame that you want to have a red background, for example. Sorry. If you hot reload, you will see that it changed the background color. So for our color switch game, I'm going to use a color such as 444444 to have a black background. It is not good. Let's decrease this value to 2222. Yes, it's better. It will be our background color for our game. You see that you can override this method to change the background. Okay, now we need to learn about a new concept of Flame game engine. We have something called component or components. Flame has a widget, not a widget tree, but a tree of components, and it works exactly like how Flutter widget tree works. For example, you have a root component, then you add your game components, and each of them can have a list of children, and it works just like Flutter widgets. In Flame, we have components, and they call it Flame Component System, FCS in short. So if you open the components, yes, you see that it calls Flame Component System FCM. So what component is? Component is a piece of your game. For example, if you have a player that moves, it can be a component. If you have a coin to pick up, it can be a component. Whether it has animations or it has sound effect or anything else. For example, if you take a look at the Flame game class, you see that it extends a component tree root. So if you open this, you see that it extends component. So what does it mean? It means that Flame game itself is a component. So on top of the component tree, you have Flame game. Then you can add other components inside this. For example, you can, in the constructor, you can call add, which adds a component. For example, my new component. Or you can call add all, which accepts a list of or an iterable of components. So in this way, you can add your components inside other components in the Flame game engine. So there are some methods that a component has. I will check them one by one. So the first method is unload. As you might guess, in unload method, you are gonna load your assets, your sound effects, or any kind of resource that your component has. For example, if we try to override this unload method, you will see that the return type is future or void. You can do this future void, which is an async function. You can do your asynchronous jobs here. So a component waits until it loads all the needed resources, and after that it is live and you can interact with this. If you don't have any asynchronous things here, you are gonna override it as a void method because you don't need to load anything asynchronously. So the other method is onGame resize. So the order that these functions are called are determined by these arrows. For example, the first method that is gonna be called is unload. After that, onGame resize gets called. What is onGame resize? It is this function. Let me remove this. And if you print the size here and do a hot reload, you see that when you change the screen size of the game, this method is getting called. Or when you rotate your phone, your screen size is changing, and as a result, this method gets called. So you are gonna do some calculations here. For example, If your component size is depend on the view size, you are gonna resize your component here. The other method is onMount, and we have an onRemove here. These two methods are getting called when you add a component to a parent and when you remove the component from the parent. For example, when you call add and you add a my component here, let me overwrite the onRemove print my component dot onRemove and onMount. And also let's override the onload method to see how it works. We have a void here. We are not going to return this. My component.unload. Okay, when the game starts, for example, in onMount, we are gonna add this component, and after a delay, feature delay, 1 second, we are gonna remove the component. And let's keep a reference of this component. Late my component, and we are gonna assign this component here. And after 1 second, we are gonna remove this from our game. So let's run this to see what happens. As you see, onload gets called, and after that onMount, and after that onRemove. The point is that onload only gets called one time. For example, if we have a component that we need to reuse it, we are gonna load the assets or resources one time, and after that we can add or remove it from a parent or other parents. For example, we can add a parent. We call it class my parent, my test parent, which extends a component, and it is just a test component. My parent 1 and my parent 2. So we are gonna add my parent 1 here and my parent 2 here, and the type is my test parent. Yeah. And instead of adding and removing the component to the game, we are going to add and remove them to the parents that we added. So we have the game component on the top of component tree, and then we have 2 parents, and in each parent we are going to add and remove our component to see what happens. Let's remove this and replace it with my test function, and it is a void function. It is async, and here we are going to, so let's create the instance of our component, but we are not going to add it yet, just creating the instance. So here we added 2 parents, we have reference to them, but we have just created our component without adding it to the game class. In the test function, we are going to say parent1 dot add our component, and we are going to wait a second, and we are going to remove it from parent1, and again after 1 second we are going to add it to the second parent, and again we are going to wait 1 second, sorry, and remove. So what we are going here is at first we add and remove our component to the parent 1, and after that we add and remove the same component to the parent 2. So let's run the app to see what happens. As you see, unload only called 1 time, but unmount and unremove get called 2 times because we added and removed, and again we added and removed the component from parent. So the point is that unload just gets called 1 time per component. Yeah, that's it. Now we need to get back to our component lifecycle. So here we have 2 important callbacks, update and render. These are 2 fundamental callbacks of each game engine. For example, you can find these 2 callbacks in Unity game engine or any other game engine that you might work on. So here in Flame we have these 2 functions too. Basically, these are the functions that are getting called per frame. For example, if you have 60 frames per second, so you have 60 times calling this function in your component. Let's have a look at these callbacks in our component. For example, at first, let me clean up our code. We understood these callbacks, we don't need them anymore. And we remove this test function, we remove the parent, and we are going to only add this component to our game. Okay, and also we can rename it to player, my player. Okay, so let's take a look at the update and render methods. Okay, let's talk about the update method. So update method is responsible for updating the component's state. For example, in our case, our player, a circle which is moving through the game, might have x and y variables, and in the update method we are going to update those variables. And in the other hand, render method is responsible for rendering our shape or our image or anything that you want to draw. For example, here you have access to canvas. You can say canvas.draw anything that you want. So before that, let me put a print here to see how much these functions are getting called. This one and also this one. So if I hot reload, as you see, there are a lot of update and render method calls. So as I said, these functions or these callbacks are getting called in every frame. For example, if you have a 60 frame per second device, this function is going to be called 60 times in a second. And also this one. One important point is that if you run the app again, as you see, at first we have update and after that we have render. Again, we have update, we have render. So in each frame, at first we try to update our state, and after that we try to render the updated state in the previous callback. What is delta time variable here? Let me remove these prints here, and suppose that we have a speed variable, for example final speed equals to 0. And also let's say that we have a y variable which is 100 by default, and also an x variable. So here we can say canvas.draw circle, and in the offset we say we want to draw this circle at x and y with a radius of 15 and color of yellow. If you run this code, you will see a yellow circle here. So this is our component. It has a state, and a state is x and y variables here. We can move this component or this player by increasing y variable or x variable. For example, if we say y plus equals 1, if I hot reload the app, it's moving towards down of the screen, because in each frame we are increasing the y variable, and as you might know, Flutter starting point for canvas is top and left. For example, here is 0 and 0, and if you increase the x variable, it moves to the right. If you increase the y variable, it moves to the bottom. So I will show you. For example, here if I say draw it at 0 and 0, it gets drawn on top left corner. If you increase the x variable, for example 300, it moves to the right. And if you increase the y variable, it moves towards down. Okay, so let's use x and y variables here. If we increase the y variable here, you see that our component is moving down. Let's say that we want to increase it by the speed variable. As you see, it moves faster because we set 3 instead of 1. So it moves 3 times faster. So what is the dt variable? dt stands for delta time, which says how much time is passed since the previous frame. For example, if you are in a 60 frame per second machine, you will get something like 1 divided by 60. You will get this variable. So it means that every 16 milliseconds you are having a frame. So let me print this variable here. And we are on a 60 frame per second machine, so you see that we have this variable. Yeah. And in the other hand, if you run the app on a 120 FPS, for example, you will have 120 times in a second, and 120 times this function is getting called in a single second. dt should be something like 1 divided by 120, this value. So suppose we are doing this line of code in a 60 FPS machine, you will have this result. But what if we run this code in a 120 FPS machine? So we will see our component is moving twice faster. Why? Because this function is getting called twice in a second. So we are increasing our variable with a twice speed in a 120 FPS machine. So you need to multiply your speed with the dt. As a result, you will have a consistent movement. For example, this variable is very low. Let me increase it to 30. Yeah, so in this way, we are going to have a consistent movement across all the devices, no matter how much FPS do they have. For example, if you run on a 120 FPS, you will have a lower delta time because frames are closer together. So when you multiply this variable, you will have a lower result to increase in each frame. But if you are on a lower FPS, you will have a higher value. It makes it consistent across all the devices that you have. Now let's change our logic to add the gravity falling down our component and jumping when we hit the screen. Before we continue, I want to introduce you with other components that Flame has. So in this case, we are extending a simple component which has a basic implementation of a component. So if you take a look at the components documentation, you will have some kind of predefined components, for example, position component, or maybe a sprite component, or SVG component. So for example, in SVG component, you can pass an SVG file to allow the Flame engine to render your SVG file. For example, in our case, we might need this component because it is handling position, size, scale, angle, anchor, and other kind of things that it's good to have, because we are looking for the same features that position component has. So in this way, we don't need x and y variable anymore, but we need the speed here. And yeah, so position component has a variable called position. It is a vector2. So let me explain what is the vector2 variable. If we take a look at vector2, it is a wrapper around two variables, x and y, and also it has a lot of useful functions. For example, you have equals implementation, you have hash code implementation, you have these mathematic operators, and also you can get length of a vector, you can normalize it, and other stuff. So Flame is using this concept for storing position of a position component. So here, instead of x and y, we have position. For example, here we can say position. Okay, as you know, position is a vector2, so draw circle wants an offset. To do that, there's a function which is toOffset. If you call this, it converts a vector2 to an offset. So if you run the app, it shows that our component is on top and left side of the screen. So as you know, position is a vector2 which is 0 and 0 by default. To do that, you can update the position like this. You can say vector2 100 and 100, and it draws like here. Okay, we can add the y variable with, or maybe we can do this position unload or amount position equals to vector2 of 150 and 100, and in each frame we are going to increase it by another vector2 x is 0 and y is speed. So in this case, we need to multiply it by dt variable. So in this case, we have a falling component. By the way, we can change the speed to a vector2 variable and we can change it to velocity, and it can be a vector2 of 0 and 30. It is not final anymore, or maybe we can have it as a final variable, and each time we add our position with our velocity multiplied by delta time, it has the same result, but we have both in x and y in our velocity variable. Let's increase this variable a little. For example, 40 I think is good. Okay, so as we see, it moves with a constant variable which is not simulating the real gravity, and to do that we can have a final gravity variable which is something like 980, and here we can increase our velocity with a vector2, or we can increase our velocity dot y by the gravity times dt. So in this way we have a real gravity simulation. For example, we can change the initial velocity to 30, and as you see, it falls down something like the real gravity. It is not like the real gravity, but we try to simulate it. So now we can handle the tap event to jump our ball or our player. So to do that, we need to handle tap callbacks. So let's get back to the documentations. If you search for a tap, you see we have a tap event. You can add this mixin in your component, and after that you have on tap up or on tap down. So let me add it here, tap callback, and we have on tap down. So let me do a print to make sure that it is getting called on tap. And if we tap here, yes, you see that this method is getting called. And now we need to create a jump function here, which changes the velocity dot y to something like, let's have a variable here, final jump speed, to set it something like 250, and whenever we jump we change the velocity y to minus jump speed, because we are going to move our ball towards the top arrow. So it says, oh, it is int, it needs to be double, no worries. Okay, and if we run the app again, oh, we need to call the jump in our on tap down. So we have access to our player. Here we say player.jump, and if we run the app, yeah, as you see, we have a moving player. When you tap on the screen, it jumps toward the top, and whenever you do nothing, it falls down with a gravity like speed. Let's clear our code a little, and after that we are done. So as a recap, we have update and render methods. In update, we update the state of our component, and in render we draw or render our component. For example, here we only draw a circle. And for tab handling, you just need to add this mixin to your component. We could add this mixin to our player, but we don't want to handle the tabs on the player because it has a little space to tap and it is not good. But when we add this mixin in our game, you can tap anywhere on the screen to fire the jump method. So in our update method, we are adding velocity to our position, and in each frame, we are adding gravity to our velocity, which makes something like falling a component. And in the jump section, we just change the velocity to something that moves our component towards top. Great. So we are done with this episode. We learned about update, render, and other callbacks of a component. We got familiar with component, and now we have our player which moves around the game. So in the next episode, we are going to learn about camera and word components. Stay tuned. If you like this video or this series, please don't forget to subscribe and hit the like button. See you in the next episode. Bye bye.